forced by the wider domain or run independently. If you want to know more about the Scottish Shelf Model, you can find out more by going to our website. If you Google the Scottish Shelf Model, you should find yourself in the right place, but I will also put a link up on my final slide. Model outputs from the Scottish Shelf Model are available to the wider scientific community, and the main available output from the Scottish Shelf Model is a 1-year model run using climatological forcing to represent an average year. So this forcing has been averaged over a 25-year period and applied to the model, which has then been run for a single year. The benefit with this is that you only have to run the model for one single year and you get a product which represents average conditions. The disadvantages with this is that you lose a lot of information in terms of seasonal and annual variability, which in some situations can be very important. As an example, storms, which can have a large effect on the hydrodynamics, are all smoothed out over a 25-year period, since they don't always happen at one particular point in time every year. And in some situations, it can be very important to capture this information, especially when doing tidal energy resource assessments or connectivity studies, which rely on particle tracking over the winter months. So this has limited the potential usefulness of the Scottish Shelf Model, and this then takes us to the Scottish Shelf Waters Reanalysis Service. So the objective with the reanalysis service was to produce a 25-year hindcast of the wider domain Scottish Shelf Model, where the model is forced using CMEMS products. As I mentioned earlier, this is a collaboration between us at Marine Scotland Science and the National Oceanography Centre in Liverpool. And the model runs have been developed and are executed by NOC, while Marine Scotland Science are responsible for the dissemination and demonstration of the service. And as a result, we will have 25 years worth of model output spanning from 1993 to 2017. And this will include both hourly and daily means of currents, sea surface elevations, temperatures, and salinities. Most of the model outputs should be available for download sometime at the end of November, and this data will be freely available to anyone who wishes to use it. A product like this, which includes the interannual variability, will improve accuracy and also increase the usefulness of the Scottish Shelf Model. The existing climatology, where the forcing has been averaged over a long time period and then applied to the model, running the model only for a single year, is hard to validate since you can only really compare it to other climatological products. With this new hindcast, you can perform a more extensive validation, which will then increase the user confidence. So we are really hopeful that many will benefit from this improved 25-year model run of the Scottish Shelf Model. So this is kind of the different stages of the project. So the first step was to build boundary conditions. The next step was then to set up the assimilation, to then go on to building atmospheric forcing and freshwater forcing. The model was then calibrated and validated before the model was set running for the full 25 years. CMEMS products were used in 3 of these stages. So the CMEMS products were used in generating the boundary conditions for the assimilation as well as for the calibration and the validation. So in total, there are 6 CMEMS products used for the reanalysis project, all listed here. These have all played a vital role in generating a product with high user confidence and accuracy. So this list includes a combination of other hydrodynamic models as well as some observational data sets. So to generate the boundary conditions, the majority of the information has come from the Met Office AMM7 model, and for the assimilation and the calibration and validation, the data products that have been used are based on observations. Some applications will really benefit from this new and improved product, especially applications where interannual variability is important. I thought I'd mention a few to give you a flavour of the versatility of the model. So first of all, we have the assessment of impact of renewable energy installations. So this will include things like assessing and modelling how much energy can be extracted from tidal turbine installations and what possible effects this can have on both near-field and far-field hydrodynamics. Another example is using the Scottish Shelf model for connectivity studies for aquaculture or benthic species within marine protected areas and other habitat areas. So this involves using the output from the model to force particle tracking simulations. And this allows you to predict connectivity between different areas for different species. And this has previously been done looking at, for example, sea lice dispersion or horse mussels and flameshell habitats. You can also use the Scottish Shelf model to force smaller local models. We do this in-house to force our subdomains, and others do it to force their own smaller local models as well. The Scottish Environmental Protection Agency, SEPA, used the Scottish Shelf model to force their MIC models, which they then used to determine the suitability of an aquaculture proposal based on the resulting waste dispersion from multiple sources and the risk posed to sensitive features. So this is regularly done by SEPA when screening new aquaculture site applications. The model output can also be used for emergency response in the case of, for example, an oil spill in the North Sea. And there are loads of other applications where the Scottish Shelf model can be used, and it's already playing a vital part in many research projects. We hope that this extended model run will increase the range of Scottish Shelf model applications. If you're interested in the reanalysis service, or if you want to know more about how the reanalysis service is set up, or how to access the data, or anything regarding the Scottish Shelf model as a whole, you can go to our website, or you can send us an email and we are happy to answer any of your questions and assist you into accessing the data. Thank you.
So it was a great presentation. No need to question and answer mode because we don't have the speaker with you right now. I propose you to share my screen before the coffee break, the virtual coffee break, to show you how to use the information from the participant manual and to explain you how to access the Jupyter Hub. Okay. So I hope you see my screen now. Try to zoom a little bit after that. So this is the participant manual you should receive. And if not, you will receive it soon after the webinar or tomorrow. Okay. And in this participant manual, so let's try to zoom. Okay. You have information about the speakers, the partners, etc., etc. And then you have explanation about the different tools we are using during these workshops. And for your practical session, you will access to a Jupyter Hub thanks to this link, and you will receive soon after the webinar this evening or tomorrow morning the credential to access this platform. Okay, so if I'm logged on this platform, so if you don't know this Jupyter environment, so it's like that. So you have your home directory here with a launcher here, and you have the notebooks available for the different regions and for the Norway Shelf available here. Shared notebook, okay, Norway Shelf, and you have access to all these different directories: in situ products, physical, bio, wave model products, and ocean color products. So if you want to have a look to this Jupyter notebooks, you can double click and have access to the Jupyter notebook. But be aware that if any change you can make on this notebook will not be saved. So you have to clone the notebooks, to copy the notebook on your home directories and work directly from your home directory to save your modification. Okay, so let's see how to do that. It's explained in the practical manual. Okay, so there is information. So as a reminder, you cannot work directly in the public folder. So you have to copy on your home directory. So you have just to copy the line. So for example, I want to copy the Ocean Color Product Jupyter notebook. So I copy the line, Control C, come back on the Jupyter Lab. I'm going to, on the launcher, I choose to open a terminal, and on the terminal, I just paste the line. Okay. Okay, no such directory. This is perhaps a little mistake in my code. Training Norway shelf. Okay, 05 Jupyter Notebook Ocean Color Products. No, it's the correct way. So let's try it again. Share notebooks. So I tried this before the the workshop and it worked, and now it's not working. Okay, so what's happened? Let's try to, if I make this, I think it is that. Let's try. Okay. Okay, that's right. No. Okay, so there is a little mistake on this one. I'm so sorry for this demonstration. Let's try the view. Perhaps it's not the good. We will make the correction of these lines to be sure that you can copy. Oh my God. Okay, so add space. Yes, I tried to add space. Space are missing. Where you say that? Here. No, okay. I'm not very good with that. So I will let the service desk and my colleague to correct these lines. Yes, it's. I have to add space, but normally it's working. I don't know exactly what happened. I'm so sorry. Because here, perhaps I know. It's not the good. The good format. Okay, so I will check that later, and I will give you on the chat, and we will correct the document to let you the good command line to go on your home directory, to copy on your home directory. So normally it's very simple. You have just to do that, and after you can access on your home directory directly the notebook, like it is the case, for example, here. So this is the North Sea indicators, Jupyter Notebook indicators. And you have just to go step by step, cell by cell, with this clicking here. So you have just to launch each cell after each cell and read all the explanation from the experts. Okay. One thing more before the break. I want to share with you, yes, the YouTube web page of the Copernicus Marine Service. You can have access to the playlist, and on the playlist you have a playlist dedicated for the Norway Shelf Sea with all the videos recorded by the trainers and the experts. All the videos are here, and you can have access also to a different video on the made by the service desk to understand the Jupyter Hub environment. Okay. This is the chat. This is a chat platform, the Mattermost platform. Again, you will receive a link to reset the password and to access on this chat platform to ask your questions. So you have different channel here dedicated for each Jupyter notebooks, each exercises. So you can directly ask your question, and the experts will answer your question soon. And to finish before the break, on the website you can have access to a new visualization tool, the viewer, and we have a short video to introduce this viewer and to let you dive into the ocean thanks to this layer. This tool, sorry. So I will share the video. This is this one. Okay.
Part 1, overview.
That's right. Okay.
The My Ocean Viewer has two main sections. The first allows you to choose layers. This allows you to choose the product and the variables inside this chosen product. The second part includes a screen viewer which generates ocean maps with different variables.
Okay.
It also includes a menu of diverse tools on the right-hand side, the depth selection tool and the timeline date selection tool at the bottom of the screen. Part 1, overview.
Can you hear the video?
Which variables do you want to map? By default, the viewer shows seawater potential temperature. You can add layers to your map. When you click Add Layer, you see a pop-up box displaying all the products.
Yes, the video is doubled.
You can search through free text or through the following
Yes.
filters.
Just stop sharing your
Main
screen.
variables.
I manage the video, okay?
Area.
I
Time,
stopped
including
sharing my
future,
screen.
Present, and past.
Thank you.
Source, numerical models, in situ observations, and satellite observations. Originating
Part
Center,
1.
which is a list of Copernicus Marine
Sorry,
providers.
the video is
and processing level.
backup of
You
my
can add
computer. I
products
don't
as the
understand.
favorite by clicking on the star. Then at the top of the filters column, you can see all your
You
favorites.
can put me as
You
attendee
can
if you want.
deactivate
Okay?
or
Thank you very
activate
much.
the layer by clicking on the eye. You can change the opacity of your layers.
Sorry
to
about
compare
that.
products. By clicking on the Configure Layer button, you can change the color palette for the map as well as the minimum and maximum values. Part 1, Overview. The My Ocean Viewer has two main sections. Some layers have
The
a
first
logarithmic
allows you to
scale.
choose layers.
For example,
This allows
the
you
mass
to
concentration
choose
of
the
chlorophyll
product
8 in seawater,
and the
by
variables
default, the log
inside this
button is
chosen
activated
product.
for certain products. The second part includes
can
a
click
screen
the
viewer
layers
which
button to
generates
explore
ocean
other
maps with
variables in the
different
same
variables.
dataset.
It
By
also
clicking on
includes
the
a menu of
information
diverse
icon,
tools
you
on
can
the right-hand
access
side,
the abstract
the depth
and
selection
product
tool, and the
information.
timeline date selection tool at the bottom of the screen. You can also add the layer as a favorite. Part 2. Which variables do you want to map? By default, the viewer shows by clicking the download icon, you are redirected to the Copernicus Marine catalog. When you click Add Layer, in upcoming versions, you can download an image or video of the variable you can search through free text being redirected to the Copernicus Marine website. Universe, main variables, to view the keyboard shortcuts, click on the About section at the top right-hand side of the box, and Past. Source, you can share the map you created with these layers by clicking on the Share button. This allows you to generate a short link of your map and
sorry, Fabrice, we have an issue concerning the audio. Can you stop the video on your laptop?
Part 3. Dive into the 4D ocean. To view the North and South poles, use the two arrows at the top and bottom of the screen.
Or stop the sound.
Zoom in a particular region using your mouse on your computer or your fingertips from a mobile device.
Sorry about the issue.
You can also dive deeper in the ocean by selecting various depths. Lastly, the timeline at the bottom of the screen allows you to select a particular date and even hour by zooming. You can click anywhere on the map and compare information from that selection, such as the time series and information at depth. Automatically, the selection information boxes and map are synchronized. Clicking the Points button in the menu gives you the same functionality. When you click on the Lines button, you can make a line or multiple connected lines. Press Escape, and this will give you the same selection information box with information on a time series.
Yes, guys, we have a problem with the sound of the video.
When you click on the Areas button,
so we will forward you the link to watch the video quietly by your side. This is a demonstration of how to use the viewer. We are very sorry about that. I think we are okay, Fabrice. We don't hear any more noise from your laptop.
Yes, sorry for that.
I will. It's a short video. Huh? It's quick, so I will put the video again. 4 minutes. Okay. Sorry about that. Let's begin. You can take your coffee for the time being. Yeah. Here you are.
Part 1 Overview. The My Ocean viewer has two main sections. The first allows you to choose layers. This allows you to choose the product and the variables inside this chosen product. The second part includes a screen viewer which generates ocean maps with different variables. It also includes a menu of diverse tools on the right-hand side, the depth selection tool, and the timeline date selection tool at the bottom of the screen. Part 2. Which variables do you want to map? By default, the viewer shows seawater potential temperature. You can add layers to your map. When you click Add Layer, you see a pop-up box displaying all the products. You can search through free text or through the following filters: Universe, Main Variables, Community, Area, Time including future, present, and past, Source, Numerical Models, In Situ Observations, and Satellite Observations, Originating Center, which is a list of Copernicus Marine data providers, and Processing Level. You can add products as a favorite by clicking on the star. Then at the top of the Filters column, you can see all your favorites. You can deactivate or activate the layer by clicking on the eye. You can change the opacity of your layers to compare products. By clicking on the Configure Layer button, you can change the color palette for the map as well as the minimum and maximum values. Some layers have a logarithmic scale. For example, the mass concentration of chlorophyll A in seawater. By default, the log button is activated for certain products. You can click the Layers button to explore other variables in the same dataset. By clicking on the information icon, you can access the abstract and product information. You can also add the layer as a favorite. By clicking the download icon, you are redirected to the Copernicus Marine catalog. In upcoming versions, you can download an image or video of the variable selected without being redirected to the Copernicus Marine website. To view the keyboard shortcuts, click on the About section at the top right-hand side of the box. You can share the map you created with these layers by clicking on the Share button. This allows you to generate a short link of your map and the embed code. Part 3. Dive into the 4D ocean. To view the North and South poles, use the two arrows at the top and bottom of the screen. You can zoom in a particular region using your